Okay, so now let's do a equivalent resistance circuit for where I've got a bunch of resistors all in series and parallel, all different combinations. So I want to find the total equivalent resistance of the following circuit. So let me go ahead, I'm going to put here in red, I'm going to number these resistors. So let's call that 1, 2, 3, 4, 5, and 6. All right, so what we want to do is we want to go through and take things that are obvious and combine them together, redraw the circuit, and keep repeating. All right, so let's start off with what's an obvious combination? Well, remember, things are in series if there's no junctions between them, so they just go head to tail with no splits in the wires, nowhere that the current can go to. They're in parallel if the two top sides are connected together and the two bottom sides are connected together with nothing in between. So if I look at resistor 1 and 2, you can see that their top ends are hooked together and their bottom ends are hooked together. So these two are in parallel. So I can find their equivalent resistance. Let me call it R12, so I know, put the subscripts on so I know which resistors I'm talking about. So in parallel, I'm going to do the inverses. So 1 over R1 plus 1 over R2. And then take the inverse. So 1 over 1.5 plus 1 over 2.5. I'm not going to get nice looking numbers. Here I get 0.9375 ohms. I'm going to keep a bunch of sig figs since I'm going to be combining these guys together. So if I redraw my circuit, I'm going to redraw it and I'm going to replace those two resistors, 1 and 2, with a single resistor. So let me go over here. So I'm going to start off, and now I've got this R12 there, and then I've got still 3, 4, and 5 like that, and then resistor 6 goes like this. So I've got R3, R4, and R5 like that, and R6 there. All right, so what's the next obvious thing? Are R1, 2, and R6, are those two in parallel with each other? Well, if I look at the bottom side, the bottoms are just connected together with nothing else in between. But if I look at the top side, I've got this mishmash of resistors in between. So 1, 2, and 6, they're not in parallel. How about these ones that I've started drawing a circle around? R3, R4, and R5, those guys, those are in parallel with each other, because if you look at the top sides, there's nothing but wires. If you look at the bottom side, there's nothing but wires. Okay, so in this case, it's left side and right side. So these guys are also in parallel. All right, so what do we have now? So let's call it R3, 4, 5, since that's what I'm combining. They're in parallel, so I'm going to add up the inverses. Okay, so now let me refer back to my picture for the numbers. 1 over 4.8, 1 over 3.3, and 1 over 8.1. And then take the inverse again. I get 1.575 ohms. So I'm just keeping 4 significant figures here for all of these, just so I've got some good numbers when I do it. All right, so now what do I do? Redraw my circuit again. All right, so now I've got only 3 resistors left. I've got R12, I've got R3, 4, 5, and I've got R6. All right, so now what's the next thing? So again, are R1, 2, and R6, are those two in parallel? No, they're not, because I've got this resistor R3, 4, 5 in between the top side of them. All right, what else can we do? Well, if I look at R3, 4, 5, if I have a current that's coming in to R3, 4, 5, that same current is going to go through R6, right? There's no junctions in between them. So these two guys now are in series. Okay, so now I'm going to combine those together in series, and in series, the R total, so now let's see what it's going to be. R3, 4, 5, 6, I'm combining all those, In series, I just add it. So it's going to be R345 plus R6. So R345 was 1.575 ohms plus R6, which was 6.3 ohms. And so I get 7.875 ohms. All right, we're getting there. So let's simplify that down again. All right, so I've got now still have my R12. And now that R345 and R6 are combined into one, R3456. And how did I choose to draw it there? Well, I could have drawn it anywhere. I could have drawn it here too, and it would be the same. Remember, these resistors, you can imagine they can slide like beads on a wire anywhere, except they can't go past a join, right? If you had a join in the wires here, you can imagine that the bead wouldn't be able to slide past there. And so I drew it this way just to make it more obvious what the relationship is. If you look at the two resistors, their top end has nothing but wire in between it. Their bottom end has nothing but wire in between it. And so these guys are in parallel. So now, let's see what I've got. I got my R1, 2, 3, 4, 5, 6. So I've got them all combined. So let's go ahead and call it R equivalent or R total. It's just going to be, since they're in parallel, 1 over R12 plus 1 over R3456. And again to the minus 1. So R12 was 0.9375. R3456, that was my 7.875 to the minus 1. Put that all together, I get 0.838 ohms. And now if I look, I had two significant figures in all my numbers there. So I should round that to two significant figures. So 0.84 ohms is the final answer. That's the equivalent resistance for the circuit. And again, make sure redraw it every time, because then it's obvious for you what the next combination is that you should simplify.